The objective today is to differentiate between 4-bit encoding and variable length encoding. Sounds really fancy, but I'll try to make it as simple as possible for you. Today will be a big vocab day, but that's okay. These days just have to happen, and we'll practice using the terminology throughout the rest of the unit. What we've not started is variable length encoding. We haven't started anything about this idea yet. And currently in progress is the concept of data in binary form. So that's a work in progress right there. But what's completed is the definition of binary and the definition of Boolean. They're basically both the same definition, except binary could be something referring to an actual number system versus the idea of something just being true or false, on or off. Okay, so to talk about encoding, first we need to answer what is data compression. So in signal processing, data compression, source coding, or bit rate reduction, these things involve encoding information using fewer bits than the original representation. So compression can be either lossy, or as I like to say, lousy, or lossless. So zero in here on the answer. It is taking information and using fewer bits than the original representation of that information. So in a super short form, compression is making something fewer bits. On this page, what is the difference between lossless and lousy compression? Lossless compression reduces bits by identifying and eliminating statistical redundancy. Lousy compression reduces bits by removing unnecessary or less important information. Okay, so sometimes lossy compression is not lousy at all, but in your mind, telling the difference between these two will be very important, okay? So think right here on this page, what is source coding? It says here the process of reducing the size of a data file is referred to as data compression. Now in the context of data transmission, it is called source coding. Encoding done at the source of the data before it is stored or transmitted. And this is all in opposition to channel coding. Alright, don't worry about that last part unless you're looking for things to Google, which channel coding would be a great term to Google and learn more on your own. But just fixate on the idea that source coding is the idea of making something smaller for the sake of transmission, not making something smaller for the sake of storage. So if you're struggling at this point, what is the difference between lossless and lousy compression? Here's an image example. Can you even tell the difference between the two images? Lossless compression reduces bits by identifying and eliminating the redundancy, so there is no information lost. Now, lousy compression or lossy compression reduces bits. If you're looking at this picture, the lossy doesn't seem very lousy at all. I mean, there is very little difference between these two birds. So now let's move on to what's called run length encoding. So with that in mind, I want you to figure out if this example is one of lossy or lossless compression. It says, for example, an image may have areas of color that do not change over several pixels. So instead of coding red pixel, red pixel, red pixel, and so on, the data may be encoded as 279 red pixels, all in a row, right? So this is a basic example of run length encoding, and there are many schemes to reduce file size by eliminating redundancy. And so if you're interested in hardware at all, or the performance of hardware, or even game systems, I highly suggest this YouTuber named Linus. Now, data compression as fast as possible is a good video that's completely on topic with our objective today. So let's move on to the idea of what the pros and cons of streaming video could be. So video compression is obviously another example we can use other than just the image compression. So thinking of Netflix, really. A compression scheme for a video may require expensive hardware for the video to be decompressed fast. Now, you need that decompression to happen fast enough so you can view it. The option to decompress the video in full before watching it may be inconvenient or require additional storage. So essentially, instead of just sending the entire video, you could maybe use source coding to make the transmission itself smaller and thus just stream the video. And as long as the streaming service is ahead of the client, you're going to be good. There should be relatively seamless streaming. So I'm sure everybody can say many pros of streaming video, but are there any cons you could think of? Or maybe are there any cons you've experienced while streaming Netflix or YouTube or Hulu or any of these other video streaming services? And with that in mind, I'm thinking if you need any motivation to learn today, like just think about how much this knowledge translates into money. If you become a programmer for Netflix, Oh gosh, that's just one of the most sought after programming jobs I know of. You've got it made if you get hired by Netflix. So as we wrap up this lesson, just think about like what it means to have an encoding, what it means to transmit and compress data. If you're a fan of streaming HBO Go, there's a funny show called Silicon Valley that I love. And I mean, this entire show itself revolves around compression techniques and talking about compression like we did today. Also notice this guy's shirt. It says, "I know HTML, how to meet ladies." And so that's it. Here's your DOL for the day. How is data compressed, and why is compressing files important?